math buddies, Sir Sherwin here, your math instructor. For today's video, we will be discussing all about equation of a circle. Of course, we will be guided with these objectives. First, write equation of a circle in standard form and identify the coordinates of the center and radius. And write equation of a circle in general form. X squared plus y squared plus dx plus ey plus f equals 0. To start, let's define circle. It is a set of all points equidistant to a fixed point called the center. It can be formed by slicing a right circular cone with the plane traveling parallel to the base of the cone. This means it is a conic section formed when any plane not passing through the vertex of the cone perpendicular to its axis cuts one up. A circle has a fixed point known as the center, and the segment connecting the center and point on a circle is known as the radius. And this two radii is known as a diameter. Equation of a circle can be in standard form. It can be written as x squared plus y squared equals r squared if the center is at the origin or has a coordinate 0, 0. Another standard form of the equation is written as quantity x minus h squared plus quantity y minus k squared equals r squared if the center of the circle is at hk and r is considered as the radius of the circle. On the other hand, the general equation of a circle is written as x squared plus y squared plus dx plus ey plus f equals 0, where d, e, and f are real numbers. Please take note of this one. This equation is obtained by expanding the standard equation of a circle. So this time, let's try to write equation of a circle with the center at the origin and a radius. Our first example. Given coordinates of our center 0, 0 and radius which is 11 units. Again, utilizing our standard form, x squared plus y squared equals r squared, substitute our radius which is equal to 11. Simplifying the equation, it will lead us to x squared plus y squared equals 121. This can be the equation of our circle in standard form. Another example. Coordinates of our center 0, 0 and radius measures square root of 5 units. Again, utilizing the standard form, x squared plus y squared equals r squared, substitute our r which is square root of 5. Rules in simplifying radicals. If the index and exponent of the radical is the same, we can cancel it out. Simplifying this equation, that is x squared plus y squared equals 5. Again, this is the standard form of our circle. Another example. Center has coordinates 0, 0 and radius which is 3 square root of 2 units. Again, substitute our radius 3 square root of 2 from our standard form x squared plus y squared equals r squared. So to simplify our equation, it will lead us to x squared plus y squared equals 9 times 2. 9 is a result when we square 3 and 2 is a result when we square root of 2. To simplify our equation, it will lead us to x squared plus y squared equals 18. Again, this is written in standard form of the equation of our circle. Let's also write equation of a circle with center at hk and a radius. Let's have our example. Given center with coordinates 2, 3 and radius which is 10 units. In this case, utilize our standard form quantity x minus h squared plus quantity y minus k squared equals r squared, where h is equal to 2 and k which is equal to 3. So substitute the coordinates of our center and radius in our existing standard form. So we will have quantity x minus 2 squared plus quantity y minus 3 squared equals 10 squared. To simplify, 10 squared, that is equal to 100. In this case, the standard form of the equation of our circle is quantity x minus 2 squared plus quantity y minus 3 squared equals 100. Another example. Coordinates of the center of our circle is negative 1, 6, and the radius is 13 units. Again, utilize our standard form, quantity x minus h squared plus quantity y minus k squared equals r squared. Substitute the coordinates of our center and radius in our existing standard form, where h is negative 1, our k is 6, and our radius is 13. In this case, let us also be particular with the sign of our coordinates. So simplifying our equation, we will have quantity x plus 1 squared plus quantity y minus 6 squared equals 13 squared will lead us to 169. So therefore, this can be the standard form of the equation of our circle. Another example. Center has coordinates -5, -2, and radius which measures 4 square root of 3 units. Again, utilize our standard form and substitute the coordinates of our center and radius in our existing standard form. So, we will have h which is -5 and our k which is -2, while our radius is 4 square root of 3. Let us simplify. The equation will become quantity x plus 5 squared plus quantity y plus 2 squared equals 16 is a result when we square 4, and 3 is a result when we square square root of 3. 16 times 3 will lead us to 48. Therefore, the standard form of the equation of our circle can be quantity x plus 5 squared plus quantity y plus 2 squared equals 48. This time, let us transform quantity x minus h squared plus quantity y minus k squared equals r squared into the general form, which is x squared plus y squared plus dx plus ey plus f equals 0. So let's do this one as we transform quantity x minus 2 squared plus quantity y minus 3 squared equals 100. So first thing that we need to do is to expand the standard equation of the circle. This means we will expand quantity x minus 2 squared into a perfect square trinomial and quantity y minus 3 squared into a perfect square trinomial. In this case, expanding quantity x minus 2 squared will lead us to a perfect square trinomial which is x squared minus 4x plus 4. Copy the plus sign. Expanding our square of a binomial y minus 3 squared, that is quantity y squared minus 6y plus 9. Then copy equals 100. So let's try to rearrange the expression into general equation of a circle. So in this case, we will start with x squared followed by y squared followed by the term containing x followed by the term containing y, then our constants 4 and 9. Again, copy the right side of our equation which is equal to 100. Then, we will apply subtraction property of equality as we transpose 100 from the right side going to the left side. So, the simplified equation becomes x squared plus y squared minus 4x minus 6y minus 87 equals 0. This is now the general equation of our given circle. Let's have another example. Quantity x plus 1 squared plus quantity y minus 6 squared equals 169. To write this one in general form, all we need to do first is to expand the standard equation of the given circle. This means we will expand quantity x plus 1 squared into a perfect square trinomial, that is x squared plus 2x plus 1, while expanding quantity y minus 6 squared, that is y squared minus 12y plus 36. And of course, it is equal to 169. Then, we will rearrange the expression into general equation of a circle. That means x squared followed by y squared, then the term containing x, term containing y, and the constants 1 and 36. Again, that is equal to 169. Then we will add constants 1 and 36. The sum is 37. Simplify the given equation using subtraction property as we transpose 169 to the left side of our equation. So the simplified equation becomes x squared plus y squared plus 2x minus 12y minus 132 equals 0. This time, let us write quantity x plus 5 squared plus quantity y plus 2 squared equals 48 in general equation of the circle. First, expand the standard equation of the circle. This means quantity x plus 5 squared can be written into a perfect square trinomial which is quantity x squared plus 10x plus 25. While expanding quantity y plus 2 squared, that is y squared plus 4y plus 4. Again, copy right side of our equation which is 48. So we will rearrange the expression into general equation of a circle, x squared followed by y squared, then terms containing x, terms containing y, and of course constants. Then it is equal to 48. Combining 25 and 4, that is 29. Transpose 48 to the left side of our equation using subtraction property. Therefore, the simplified equation is x squared plus y squared plus 10x plus 4y minus 19 equals 0. This is the general equation of the circle. Let us also transform the general equation of our circle into quantity x minus h squared plus quantity y minus k squared equals r squared. Let's have our first example. Let's transform x squared plus y squared minus 2x plus 12y plus 7 equals 0 into standard form. So what would be our solution? So in this case, we will group the terms containing x and the terms containing y. So x squared minus 2x will be grouped. Y squared plus 12y will be grouped as well. Then copy the constant 7 equals 0. So after this, we will transpose 7 to the right side of our equation. In this case, we will utilize subtraction property of equality. So we will make our group terms a perfect square trinomial. So to make this one a perfect square trinomial, all we need to do is to get the half of coefficient x. In this case, half of negative 2, it's negative 1. Squaring it, that is 1. Whatever added on the left side will also be added on the right side of our equation. This time, let's also make y squared plus 12y a perfect square trinomial as we get the half of coefficient y and square it. So half of 12 is 6. Squaring 6, that is 36. Again, whatever added on the left side of our equation will also be added on the right side of our equation. This means x squared minus 2x plus 1 becomes a perfect square trinomial, and we can express this as a square of a binomial. So x squared minus 2x plus 1 as a square of a binomial becomes quantity x minus 1 squared. While y squared plus 12y plus 36 can be expressed also in a square of a binomial, that is quantity y plus 6 squared. Then combining negative 7 plus 1 plus 36 is 30. This is now the standard form of the equation of our circle. Let's have another example. X squared plus y squared minus 5x plus 14y minus 2 equals 0. So we will group the terms containing the same variable. In this case, our equation can be written as x squared minus 5x plus y squared plus 14y minus 2 equals 0. Then, constant negative 2 will be moved to the right side of our equation using addition property of equality. Then, we will make our group terms a perfect square trinomial. To make x squared minus 5x a perfect square trinomial, all we need to do is to get half of negative 5, that is negative 5 halves, squaring it, that is 25 over 4. Whatever added on the left side will also be added on the right side of our equation. Same as true with y squared plus 14y, we will add third term to make it a perfect square trinomial. In this case, we will get half of coefficient y, which is 14. Half of 14 is 7. Squaring 7, that is 49. So we will add again 49 on both sides of our equation. Then, we will express x squared minus 5x plus 25 over 4 as a square of a binomial, and that is quantity x minus 5 halves squared. While y squared plus 14y plus 49 will also be written as a square of a binomial, and that is equal to quantity y plus 7 squared. Then, combining 2 plus 25 over 4 plus 49 is the same as 229 all over 4. So, quantity x minus 5 halves squared plus quantity y plus 7 squared equals 229 all over 4 is considered the standard form of the equation of our circle. This time, let's find the center and radius of a circle, given the following equation. Let us have our first example. Find the center and the radius of the circle x squared plus y squared equals 81. So what would be our solution? The equation given is x squared plus y squared equals 81, and that is similar to x squared plus y squared equals r squared, where center of the circle is at the origin. In this case, the coordinates of our center would be 0, 0, while radius is equal to 9. So therefore, center is at 0, 0, and radius is 9 units. Let's have another example. Find the center and the radius of the circle, quantity x minus 1 squared plus quantity y minus 4 squared equals 144. This equation is the standard form of our equation when center of the circle is at hk. In this case, we can determine already the center, which has a coordinates 1, 4, and the radius, which is equal to 12. So therefore, center is at 1, 4, and radius is 12 units. Another example. Find the center and the radius of the circle, quantity x plus 3 squared plus quantity y minus 6 squared equals 23. So this is the standard form of our circle when center of the circle is at hk. So coordinates would be negative 3, 6, and the radius is equal to square root of 23. Therefore, we can consider that the coordinates of our center is at negative 3, 6, and the radius is square root of 23 units. Find the center and the radius of the circle. X squared plus y squared plus 2x minus 12y minus 132 equals 0. So, this is the general form of our equation. And to determine the center and radius of the circle, all we need to do is to transform this one in quantity x minus h squared plus quantity y minus k squared equals r squared. So in this case, we will group the terms containing x, we will group the terms containing y, and transpose constant to the right side using addition property in this case. Then we will make our expression x squared plus 2x a perfect square trinomial by getting half of coefficient x and square it. So half of 2 is 1, squaring it, that is 1. Whatever added on the left side will also be added on the right side. Then we will also make y squared minus 12y a perfect square trinomial by getting half of negative 12, which is negative 6, squaring it, that is 36. So we'll add 36 on the left side, likewise add 36 on the right side of our equation. Then, the simplified form becomes quantity x plus 1 squared plus quantity y minus 6 squared equals 169. This is now the standard equation of a circle given coordinates of our center, which is negative 1, 6, and the radius, which is equal to 13. This time, it is your turn. Write the standard form and general equation of the circle given the following center and radius. And let's find also the center and radius of the circle given its equation. There you have it. Hope you learned something new today. God bless us all.